Good morning students. Today we are going to learn about Vhdl. Okay. Vhdl means very high speed integrated circuit hardware description language. It was developed in 1980s. It is used to design digital systems. There are two languages. One is Vhdl, another one is Verilog. Both are used to describe the hardware components. It is a IEEE standard language. IEEE means Institute of Electrical and Electronic Engineers. It can be synthesized and implemented in programmable logic. Synthesis means the process of converting Vhdl code into circuit. Okay. We already studied C language in the 4th semester. In C programming, we can view only the output of any design. Okay. But in Vhdl, you can view the output as well as circuit of the design. Okay. Next, what is Vhdl? Vhdl means very high speed integrated circuit hardware description language. Why we are using Vhdl? It is used to design digital systems. Next, we will see about general format for Vhdl program. This is the general format for Vhdl program. Okay. If you take any Vhdl program, it consists of two parts. One is entity, another one is architecture. Okay. So first line, entity name is. Entity name is username. User can give any name. Okay. Entity means it like module. Okay. So inside entity we are declaring the input output ports of the design. Third line is end entity name. Okay, this part is over. Next, architecture. In the architecture part, first line is architecture. Architecture name of entity name is. Architecture name and entity name both are user name. User can give any name. Okay. Next, you have to write begin. The last line, end architecture name. Okay. Inside architecture, we are defining the actual logic of the circuit. Okay. Next, we will see about Vhdl program for AND gate. Okay. So here, AND one is the entity name. Okay. So first line entity, next entity name, then is. Okay. Here I am using AND one is the entity name. Okay. Next, port. Here I am declaring ports of the two input AND gate. Okay. So A and B are the inputs, Y is the output. So A comma B colon. So A and B are inputs. So I am using mode in. Okay. A and B both are binary values. So here I am using bit. Okay. Next, Y is the output. So Y colon out. Y is also binary value. So I am here using bit. Okay. Next, third line end architect. End entity name. Okay. So entity name is and one. Next, architecture. So architecture, next architecture name. Here architecture name is architecture 1 of and 1 is the entity name is. So architecture 1 of and 1 is. Next, you have to use begin. Okay. The last line, end architecture name. Here architecture name is architecture 1. So end architecture 1. Okay. So here I am defining logic of the AND gate. So here we are writing the program for AND gate. So Y is equal to A and B. So Y less than equal to A and B. So A is ANDed with B. Then the result will be stored in the Y. Okay. So in Vhdl program we are using less than equal to instead of equal to. Okay. Next we will see about Vhdl program for OR gate. So this is the Vhdl program for OR gate. So first line entity name is R1 then is. Okay. Entity R1 is the entity name. Next we are declaring the input output ports. Here also I am taking two input OR gates. So A and B are inputs, Y is the output. Okay. So A comma B colon input. So I am using mode in. A and B both are binary values. So here I am writing bit. Next y is the output. So y colon out. Y is the binary value. So here I am using bit. Okay. So instead of bit you can use STD logic. STD logic means standard logic. Okay. Next line end entity name. So here entity name is R1. So end R1. Next architecture. So architecture 1 of R1 is. So architecture name is here architecture 1, entity name is R1. So architecture 1 of R1 is. Okay, next you have to use begin. In the last line end architecture name. Here architecture name is architecture 1. Okay, so next inside architecture I am defining logic. So y is equal to, this is Vhdl program for OR gate. So here we are writing the program for OR gate. So y is equal to A or B. So y less than equal to A or B. Okay. Next we will see about Vhdl program for NOT gate. So entity, next entity name is. Here I am using not one is entity name. So entity not one is. Next I am declaring input output ports. For NOT gate only one input, one output. So A is the input, Y is the output. So port A colon A is the input. So here I am writing in. Next A is the binary value. So I am using bit. Next Y is the output. So Y colon out, Y is the binary value. So here I am writing bit. Okay. Next third line end entity name. In this program not one is the entity name. So end not one. So next architecture part. Architecture name of entity name is. So here architecture name is architecture 1. Not one is entity name. So next you have to write begin. In the last line end architecture name. So architecture name is architecture 1. Okay. So we are writing the program for NOT gate. So y is equal to A bar. So in Vhdl program y less than equal to not A. Okay. Next we will see about Vhdl program for NAND gate. Okay. So first entity. So entity, next entity name. In this program NAND 1 is the entity name. So entity NAND 1 is. Next I am declaring input output ports. Okay. Here also I am taking two input NAND gate. So port bracket A comma B are colon in bit. So A and B are inputs. So I am using mode in. A and B are binary values. So I am writing bit. Next Y colon out bit. Y is the output. So I am using mode out. Y is the binary value. So here I am using bit. Next third line end entity name. Entity name is NAND 1. So end NAND 1. Okay. So entity part is over. Next architecture. So first line architecture name of NAND 1 is. So architecture 1 is architecture name. NAND 1 is the entity name. Okay. Next you have to write begin. In the last line end architecture name. Architecture 1 is the architecture name. Okay. This is the Vhdl program for NAND gate. So y is equal to A NAND B. So y in Vhdl we have to write y less than equal to A NAND B. So next we will see about Vhdl program for NOR gate. Okay. So first line entity name is here NOR1 is the entity name. Next I am declaring input output ports. Here also I am taking two input NOR gate. So A and B are inputs, Y is the output. So port open the bracket A comma B colon. So A and B are inputs. So you have to write in. The next A and B are binary values. So bit. Y is the output. So Y colon out. Next Y is the binary value. So bit. So third line end entity name. So entity name is NOR1. So end NOR1. Next architecture part. So In the first line you have to write first architecture, then architecture name of entity name is. Here entity name is NOR1, architecture name is architecture 1. So architecture 1 of NOR1 is. Next you have to write begin. Okay. In the last line end architecture name. So architecture 1 is architecture name. Okay. This is the Vhdl program for NOR gate. So y is equal to a nor b. So I am writing y less than equal to a nor b. Okay. Thank you.